We have a good question from JMN 2022, which is about the stability of carbocation. So we are provided with the carbocations and we have to arrange them in order of their stabilities. Now this carbocation stability is directly proportional to the positive effects of GOC. That is, it is directly proportional to plus R or plus M. Then it is directly proportional to the positive hyperconjugation and inductive effect, positive inductive effect, right? And the stability order of carbocation in general follows the order 3 degree, then 2 degree, and then 1 degree, right? Now upon looking these three carbocations, the first one is 2 degree carbocation with no adverse effects, right? Then in option C, the carbocation is through 3 degree, no doubt, but this oxygen center which is present at a distance from this positive charge will apply its minus I, and this minus I is going to decrease the stability of carbocation. Whereas in option B, this is the option, this is the concept where most of the students get confused, that since oxygen is present at a very shorter distance from this positive charge or carbocation, so it must be exerting its stronger minus I, but the case is opposite actually. Now we know that in this oxygen there are electron pairs, there are non-bonding electrons pair, so we called lone pair, are present on this oxygen center, and just near to that, just as adjacent to that, on this carbocation we have an empty p orbital, right? So carbocation is nothing but empty p orbital. Obviously the sectet of electrons, the carbon having 6 electrons in its valence shell and an empty p orbital. Now this oxygen which is present adjacent to this positive charge or empty p orbital will donate its electron pair, will donate its non-bonding electron to the empty orbital of this carbocation, so called resonance or back bonding, right? So this is back bonding or resonance or conjugation, it is called by different names, and this will increase the stability of carbocation actually, right? Since all the atoms after this back bonding, all the atoms will have a complete octet in option B, so this option B is going to be the most stable carbocation. So option B will be having a most stable carbocation, and then option A, and the least will be option C, because there is no such case of back bonding or conjugation with the positive charge. It is however using its adverse effect of minus I. So the correct option will be BAC, which is present in option 1, right? So option 1 will be the correct option. So this will be the correct option.